Hello everyone, I am Palod, a first year undergrad student at IIT Roorkee, BTech in Data Science AI. So my project is a magic square puzzle. So first I would like to talk about my project. This project generates a magic square of odd order. Remember this? And it generates it with blanks, so it will turn into a puzzle for the user so that he has to solve it. I have written my code in Visual Studio Community as it has powerful debugging options and user-friendly interface. So the first question that might come to your mind is what is actually a magic square? So a magic square is a grid which in which we place numbers 1 to n square. Here there is 25 and the sum of each row, each column and each diagonal is same and it is a constant value. Here it is shown here. This constant is called a magic constant or magic sum. So now I will like to tell how to calculate this magic sum. As we know, it has numbers 1 to 25. So we have to calculate first the sum from 1 to 25 and divided it by 5 as it's a 5 cross 5 matrix. It means, as we know, the sum of first n consecutive numbers starting from 1 is n plus 1 by 2. So here, considering n as the index, we have to place n square in place of it. So the sum will be n square plus 1 by 2 and divide it by n as there are n rows. So for an n cross n square matrix, magic square, we have the magic constant n square plus 1 by 2. The libraries I included in my code are IOStream, which is used for basic input and output operations, IOManip, as it will help to format the puzzle so that it looks clean. I use manipulators like setwidth. The vector, I will talk about it after this slide. It's a dynamic array to store the magic square. Random, this I use the random library to generate blanks randomly in my puzzle so that they come new every time I run my puzzle. Algorithm, this is a part of the standard template library in C++. It provides useful functions like shuffle and pair, which I'll show how I help my puzzle. So let's start with vector. Vector is a dynamic array that can grow or shrink in size automatically. So the size of vector is not fixed, which is a problem with array, as we all know. It is also a part of the standard template library. The syntax of vector is as shown. Here we are defining a vector which has each each its each component as integer, and vec is the name of the vector. And so in my puzzle, I used a square. So I defined a vector in which each element is also a vector. So this will actually make a square. Like first element will go like this vector, second element here, and so on. Another notation I used here is this brackets. So this tells that the size of the vector, which means the number of elements, is n, and each element is this value, which again tells that the number of size of the number of elements is n, and each element here is 0. So this will actually provide us first 0, 0, 0, first row, second row 0. So it's actually providing a square with each entry as 0. So now some member functions of vector which I will be using. So first v is just a vector defined. So v dot pushback x. This will add element x at the end of the vector. Like there is a vector storing data 2, 3, 5, and I put v dot pushback 4. So the new vector will be 2, 3, 5, and 4. This is just like array, this will give the index element. V dot size, this will return the number of elements. Like if a vector is 2, 3, 5, 4, and we put v dot size, it will return 4. Next, I would like to explain about random. It is used for generating random blanks in my puzzle. The syntax is given here. Random device is helps to provide different results every time I run the puzzle. MT193937 is actually an engine which is fast and reliable to generate these random variables. The next thing is algorithm. So this is very useful as it provides ready-to-use functions for sorting, searching, and randomizing elements. I use pair and shuffle from this algorithm. Pair is actually defined under utility library, but it is automatically included through algorithm. Shuffle here works with random and ensures the randomness across the quadrants. I'll explain it here. So here is a simple container just like vector, but it stores two values. Vector is a dynamic and it may store many. So the it can be used alone, but I have used it inside vector in my code. So this is just an example of it. Though the data types can be different, but I have used the same one and defined it. So now the pushback will help to when we use pushback, it will add the element just like vector at the backside. Here it will add a pair to this on the end. And first Q1 k dot first. So this refers to the flow index, and dot second will refer to the column index as I have defined them. This dot first refers to the first element of pair, and the Q1 dot second refers to the second element. The shuffle. Now, shuffle was very useful for me in this project. It will randomly rearrange elements in the given range using the random generator, which I use G as I earlier defined. Here, this G has been defined. And now, the syntax for here is Q1. It will begin from the start of Q1. Of Q1 actually contains many elements of pairs, so it will start from the first element, and the iterator will refer Q1.end as the after the last element, but it actually means that it will include till last element. It's like an open bracket and close bracket here. So random numbers are generated here with G. So the result will be Q1, the elements of Q1 will be rearranged randomly. So it will help for me to assign blanks. Now the first task was to initialize all the functions. I have tried to make it a modular way so that it will be easy for the users. So first function is magic square. It is a function to generate an n% magic square using the Siamese method. I will talk about it next. The second function is create puzzle. This will create a puzzle by making blanks in this magic square that I made earlier. Now the next task will be to display the puzzle, and next will be getting the user input. This function will take user input and check correctness after each entry, and it will display after each entry what the user has entered. Now the last step was to check if the final answer matches with the correct solution. So I made a check solution function as well. Now first we'll talk about the magic square function. It's generating the magic square. Now first we'll talk about the Siamese method. What is actually the Siamese method? It is a simple algorithm to construct a magic square of odd order. Remember, this will work only for odd order. So first step, we'll have to start with 1 at the middle of the top row. So I will explain it here. Here the top row's middle is this. So we have to put 1 here, and each number will be a one step right, one step above. So this will be working in that direction, but if it's above, like there is nothing to go, so it will go to the bottom row. And So 1 is here, 2 will be going here, and 3 will be going here. So if there is nothing on right, it will wrap around and go to here, 4, 5. Here 6 will not be placed as 1 was already placed here. So the next thing is, if the cell is already filled, we have to move one step down instead. So 6 will actually place here. 6, 7, 8, and so on, and it will fill all the numbers from 1 to n square. So now the next task was to convert this algorithm into my code. Now I explain in the next slide. See, so this will explain the magic square function I defined in the void. So the element is a square, I explained, and I use and as it will have call by reference because we can't use directly. And the integer n is defined so that the size of the vector, firstly, square is defined as I already mentioned in the vector. I have to initialize a number and num as 1 and initializing I and j the indexes because I is 0 because we have to start from the first row and j has to be on the middle, so n minus 1 by 2. And for 7, n equal to 7, it will work like j is equal to 3, so 0, 1, 2, 3. Here, first element is placed. So while the num is less than equal to n square, is I have to put all the n square elements here, 1 to 49. So square ij will be num. This will refer to this as first element. Now I have to define this I before and j before because it will be problematic when the square or the place is already filled. So they are actually, and then I minus minus because I have to go on above one, and j plus plus because I have to go on the right. And if I is less than 0, like in this position, after I minus minus, it will be minus 1. I will be converted into n minus 1, taking it to the last row. Similarly, if j becomes n, which will point here, it will actually move to the j equal to 0. So it's a wraparound. And as I was talking about this, if the square is not 0, which means it has already been filled, then we have to take I as I. So after this 7, we can't take 8 here. So we have to take I is I plus 1. So here and j will remain the same. But if in this case, for example, we can't fill here, if it has to go below it, if I is equal to n, I have to wrap around and make I is equal to 0 and num plus plus. So each number will be again increment and it will start again the loop till we get n square. So this will actually make a magic square like this in the memory. I have defined as a solution. Here I have defined a square, but in the main code I have defined as solution. Now creating the puzzle, this is actually the most challenging part of my code. So this function takes the magic square solution and creates a puzzle by adding the randomly blanks to the solution. So I have to use the random library so that the blanks are placed randomly each time the code runs. And now after this, I have to use shuffle as well to randomize the places, and now the user has to solve it. So the main challenge I was facing was how to ensure the balanced distribution. Like there may be a chance that all the blanks might flutter in one side of the square. So I have to think of a strategy, and I came up with dividing the square into 4 quadrants. This will actually help so that each quadrant has a already defined number of blanks and will ensure that cluttering does not happen. So how it did it was, as it's not an even square, so it will the quadrants are not equally divided. I've made first quadrant as 4 cross 4, second quadrant as 4 cross 3, or rather I say 3 cross 4, third quadrant is 4 cross 3 here, and the fourth quadrant is 3 cross 3. So my strategy was if numbers are exactly divisible, if the blanks are exactly divisible by 4, they will be equally divided. But if they are not, as it has higher, more number of blanks, more more number of spaces, more blanks should go here. So I defined the two integers, quad blanks and extra blanks. So let's take blanks equal to 14, for example. So 14 by 4 is 3.5, and it will truncate as it is integer to 3. So three blanks are definitely going to be in each of these quadrants, and an extra blanks feature, which is 14 by 14 and modulus function. So it will return 2. So extra blanks, the value of extra blanks is 2. So Q1 will be defined as the number of blanks in the first quadrant. So it actually is 3 plus. So this is a notation similar to if else. I use this as it look cleaner. It tells us that if for with this question mark, if this condition extra blanks greater than 0 is true, it will return 1. Otherwise, it will return 0. So this is the notation, and it starts with extra blanks. So we have actually 2 here in this case. So it will return 1, and it will also return 1, but it will return 0. So actually there will be 3 plus 1, 4 blanks here, as well as 4 blanks here, 3 here, and 3 here. So mainly this is how I divided it into quadrants, because as this has larger area, so more blanks should go here. So even if there one extra blank, it will go in the first quadrant. These are actually equal, so doesn't matter which one to put on the second one. And this will not have any extra if there is extra blanks left. Now let's go to the our code to see the function of creating a puzzle. So I defined here a vector squared that says puzzle, a constant vector because I don't want to change the solution which I defined in the magic square function, and blanks to understand how many blanks are there. So firstly we have made puzzle as solution, so it will store there, and because I'm using it in modular way, so we have to define n again, and it is easier to define with puzzle dot size. So it will generate as in case for the 7. So this is the randomly generating. This will have to randomly generate the blanks. I already defined this. This code we have already seen about dividing into quadrants. So the vector, now I've made pairs so that each one stores the coordinate of this square. Q1 will store all the coordinates that belong to quarter 1, quadrant 1, and so on with others. So let's try it for quadrant 1. As we are taking n equal to 7 for simplicity, we'll start with 0 to 7 by 2, which will actually be 3 converted. So 0 to 3 will have 4, and similarly C column will be have 4. So this will be a 4 plus 4 square, and Q1 dot pushback. Yes, this will add the elements, like first we'll go 0 0, then 0 1, 0 2, 0 3, and 1 0. So this will actually add all the elements to the quadrant 1 Q1 in a pair. Similarly, for here we have, it will start with R equal to 4 to R less than 7 to 4, 5, 6. So 3 rows and 4 columns. So quadrant 2 will be also made like this. Similarly, quadrant 3 and quadrant 4. Now the next thing is shuffle positions within each quadrant. Shuffle Q1 dot begin will start with this 0 0 0 1 and till we have till 3 3. So all the elements are first of all listed like in this order as we have put in here in the code 0001 like this. Now the orders will be shuffled due to the shuffle function. So any of this coordinate can become like 2 comma 2 can become first and so on. Similarly, I've done with Q2, Q3, and Q4. Now we have to set blanks on this. So for loop where k is less than q1, here is a 4 in the case. So 0, 1, 2, 3, 4 values will be taken. And now this will arrange like how we have shuffled these values in Q1. Q1 K will put all the values from 0, 1, 2, 3. So it can be anything values as we have shuffled it. and all these four values will be set to 0. Like if this one, Q1 is shuffled and now the first value is 2, comma 1, 3, comma 2, 1, comma 0, 0, comma 3. So these all four blanks will be converted. These all four elements will be converted to 0, which will be using as blanks later. So this is how my creating the puzzle function worked. It really was a bit challenging other than all the parts of the code. So let's move back to the presentation. The next thing is displaying the puzzle. The next function is used to display the puzzle on the screen. Now I use the set w function from imanib as it will help to align the numbers. It helps in creating the space so that the grid looks cleaner to the user. And I represent the back blank cells with underscore so it is clear for the user to fill this box. The function is defined here with I've used now the puzzle has actually been created on the create puzzle, so I have defined it as constant and calling by reference. So int n will be defined as a puzzle dot size as I explained before. Now the next thing is a for loop is created so that for displaying the puzzles are from this will represent the rows and this will represent the column. So if the elements, as I said, are 0, which we have made in the create puzzle, the it will see out the underscore with a blank space so that it is well spread. This and if it is not 0, which means what we have already created in the solution magic square, other elements, so they will be displayed as it is. So this displays the puzzle on the screen. So next target is to getting the user input. Now this allows the user to fill in the blanks of the magic square. This is also a long code, like creating the puzzle. Now if the it actually creates blanks and it will check if the value entered is correct and or not as as the user gives on, on every value he puts. Now this doesn't allow the users to change the non-blank cells in the puzzle as we have already made it constant, and also doesn't allow to enter the values of out of the range. So it allows users to change the entered value, but the value he has entered because it can be correct or incorrect, but it doesn't allow to change which are already not blanks. So it will always update and display the puzzle after each input, showing the progress. So let's move to the code as well. Get user input will firstly I've designed the user answer as a new square which will be converted after each attempt of user, puzzle and solution as they are already defined. So user answer is firstly made into puzzle. So and n will be defined. So firstly we have initialized blanks equal to 0. So counting the blanks after each one. So it will count it. If this is 0, the simple for loop, it will count the number of blanks and there will be and displaying the number of blanks to be filled. Well, now this task comes where we have to take the user input one by one. So I've defined this integers as row, column, and value. So see, the first thing is it will tell the user to enter the row or column which he wishes to fill in the way that a normal index works. Like it will convert the 0001 into 1 comma 1, 1 comma 2. The simple way it works in and so this that's why we have used row minus minus and column minus minus as if the user enter 1, it will tell the program to display 00. So if the user has entered something after we have converted it to row minus minus, if it is less than 0 or greater than equal to n, which means it is going to outside the square, similar to column, it will it is an invalid position. And similarly, now I will prevent user from editing this already filled puzzle. So if it in the puzzle already this is not equal to 0, which means it's already filled, it will not allow the user to do it. And it will continue, which means it will start again. Continue works like break, but it's little different. Break will take you out of the loop, but continue will just not display anything after the this and again put it back to the loop. So, so the next thing it allows change if user has already filled the so that he can correct mistake. Like if in the user answer square, if the row column is not fixed, like it's not zero, like he has filled it already, it will provide a choice because it can be the incorrect value. So it will tell that you have already entered here to make sure if the user want to change it. And if he has not changed it, let's move again to continue and again start. But if he has changed it, so it will now taken it as another input. So it will ask for the values to be assigned and then it will take the value. And if the value is equal to what in the solution is, which means it's correct, it will display correct after each entry. And the user answer matrix will change this value to value. Otherwise, also it will change it itself, but it will show incorrect. So user has to understand that he has to attempt it again. So now we have to count the blanks again after this. Simply writing blanks minus minus will not work here, as we are allowing the user to change the input. Otherwise, it will not work. So we have to count the blanks again in the same way using the for loop. If we use blanks minus minus, it will just create a problem as we have to want to change the values here. Um, so now we have to display this updated puzzle here the same way as we use the display puzzle function. It's just work like that, but now it's working for user answer. So this square will be displayed after each entry and as it is inside the while loop. So this will work till the whole puzzle is filled. And next, I'll again go to my presentation. So the next thing is checking the solution. Now this function will allow us to check the solution if the user's final period is actually the original solution. It will is a bool function, so it will return true if the entire puzzle matches. Otherwise, it will return false. So it is used to declare whether the user solved the puzzle correctly. So it has defined this user answer and solution to compare those, and is defined here. So it will check each value with R and see if the each value any of this value is not equal to solution, it will return false. Otherwise, it will return true. It's a simple bool function. Check these values. And now let's move to the main function. So main function, I have defined n as 7 here and blanks as 15. I can change it anytime. Like I can also allow the user to try if he wants to make it like easy, medium, hard, defining blanks in the same way, as well as n can be changed to any odd value. Only odd values, as I told about the CM is. So I just put 7 and 15 for simplicity. Like if I fix n equal to 7 and ask the user for easy, I can put blanks equal 12, 13, something like this. If medium, like 16, 17, and hard, around 20. So I can do this, but I just made for simplicity to show my program. First, we have to define those squares with vector, solution, the puzzle, and user answer. I have defined all these. Now let's just firstly we'll generate a magic square, which is the magic square function as I've defined. The solution is the so matrix which will be given and n is defined as this size, which I already defined as 7. So it will generate a 7 plus 7 magic square. Now the next function will be creating the puzzle. It will, with the help of the solution, the puzzle will be firstly copied and then the blanks will be inputted like all the dividing in quadrants and putting the zeros on this. Now it's the time to display the puzzle. We'll display puzzle with blanks in place of zeros and it will display it on the screen. The next task is to get the user input. The user will Right, put each value on this, and it will check after each entry the user has entered correct. And finally, the whole result is checked with this check solution bool function. And if this actually is correct, it will return congratulations, you have solved the puzzle. But if it's not correct, so it will take some answers are incorrect. You have to try again, and it will return zero. So the next thing I show is how this output windows will look before and after solving. Firstly, it will see the puzzle looks like this, and after the user input, if he has put it correct overall, it will become like this. Congratulations, you have solved the puzzle correctly. So now let's move to the whole code from the starting. So as I've told, I've defined all the libraries, I've explained all of them. Next is using namespace std. It is very important as most of these functions I use are actually defined on the std. So firstly, we have initialized all the functions as I explained this magic square, create puzzle, display puzzle, get user input, and check solution. Then I've made the main function as I've explained about it. This will create this puzzle square. So now I've defined each function after this. This makes your code look cleaner and easy for the person to understand if anyone else wants to read it. Firstly, it is a magic square function with this Siamese algorithm. Next, I created the puzzle with a random and shuffle right quadrants as I already explained. Then it's a display puzzle to display it. User input this function. I explained it really well already. So, and the next part is the check solution. So it will return true if the solution is true. So now let's try to solve the puzzle or try to make it. I'm going to run this. This see these are blanks generated, also not completely randomly, but they are actually well spaced, so it will not be hard for the user to solve. Now, first of all, let's calculate the magic square constant. So for 7, so it will be n square plus 1 by 2, 7 into 49% 50 by 2, so it will be 7 into 25, which is actually 175. This, and you can validate from taking this across this that it will work. So now it's our task to fill it. First, I will enter the row number. Here, the row is 2. Let's firstly fill this something easier. Like this will be easier to fill. The first is 3, column is also 3. Now let's enter the value is 175 minus all these values. It will come up to be 8. Let's see if it's correct. It shows it's correct, so now it will put all the other values one by one. Let's speed run this. So now let's try to do something different. Like I entered a wrong value, what will happen? Like if I entered here something like let's put 3 here only. It will show it's incorrect. So you have to try again. So I can try it later as well. Like first put 2 and 6. If I don't find it, how it's what will be the value? So it shows correct. So now let's try it again with 2 and 5. Do you want to change it? Yes, I want to change it. Now value for 2 and 5 it is 18. So now it shows again that it's correct. Now let's try it 3 and 5. Okay, so I've by mistake put, so it will again ask me to if I want to change it. By mistake, I put it 5 and 1. I wanted to keep it 5 and 2. So this is also a helpful function. If by mistake, if he has done something wrong, he can change it. So let's put no here. I don't want to change it. So again, I'll ask the row number 5 and 2 and putting it 15. Now let's move to 6. 6 with now here it will come 3, 6, 7, and 12, 7, 1. And of entering the last value, 7 and 6 is not blank, so I have to change it to 7, 5, the last value, which is actually 2 here, and it will show it updated puzzle. So congratulations, you have solved the puzzle correctly. This is all that I have to show you. This is work. Hope that my explanation has helped you, especially in explaining the new libraries like random and vector I have used. They have a little bit difficult syntax, and also the algorithm for this Siamese algorithm. This might not be that hard to understand, but this was quite challenging understanding all the quadrants. I have to think about this. And also the user input function, this so that this will also to understand how can the user can change the input here. This how will it look? This is how my puzzle is actually done. So let's return to presentation. It's, and it's actually over. Thank you from my side. Hope you will like this explanation.